Welcome back. This is an Aleks homework video on writing the rate law implied by a single mechanism with an initial slow step. So if you are trying to come up with a rate law from a mechanism that has more than one step, then your rate law can only be as fast as the speed of whatever is the slowest step in your mechanism. Each one of these steps has a different rate constant. It's happening at a different speed because really it's essentially a different chemical reaction happening in sequence. So we would like to write a rate law. We can only write a rate law for the slowest step. Whatever is the bottleneck, whatever is holding up the mechanism can determine the speed or the rate of the entire chemical reaction. So we're looking for whichever step has the slowest rate. We want to find the slowest, and then whatever is the slowest, that's going to be the chemical rate for the entire chemical reaction. If you have the first step as a slow, then that's actually the easy way to do it. If the second step was slow, what you're going to find here is that in the second step, you've got an intermediate. You've got something that was made in the first part of the reaction that was used up in the second, and you never see it again. So that intermediate is short-lived, and it's basically only there during the initial parts of the chemical reaction, and then you don't see it as either a reactant at the beginning or as a product at the end. For that reason, you cannot use it as part of your rate law. You can't say the concentration of this intermediate is part of what I want to do because that intermediate's not there at the beginning and it's not there at the end. So if you have a slow step with the second step or one of the subsequent steps that has an intermediate in it, you're going to have to do a lot more work. But this one is not that way. You've got the slow step as being the first step, and if this is the slow, if that's the slow step, then really your entire rate is nothing more than the rate of the breakdown of your tert-butyl bromide at the beginning. So you're going to have the rate is going to be the rate constant K times CH3 CBr, okay, and that is all that it is. That's simply the breakdown of that initial reactant is going to be the rate of the entire thing, since your first step is your slow step. Now the balanced equation is simply you want to ignore your intermediates because it's going to cancel on both sides. So you're going to essentially add up everything that's not an intermediate and put everything that's on the left, everything that's on the right. Okay, so the balanced equation. Now remember, Aleks needs the states. So if it's a liquid or a gas or aqueous, you need to include that. So this is simply going to be the CH3 CBr, and you need to include that that's aqueous, plus, now I'm going to add the hydroxide, which is on the step 2. So this is OH, negative aqueous, and then that's everything that's on the left. So here's my arrow. Now on the top I've got the Br, and it's aqueous, and on the bottom I've got the CH3 COH, and it's aqueous. I ran out of room, so you have to include that. This is very straightforward and it'll only take you a minute or two to do it, so I hope this helps you.